Hello everyone, today I will show you briefly how to use CSI Column version 10. This is the latest version of CSI Column. You just open CSI shortcut, and for the top left side, open project, save project, save a project. You cannot save project and save a project because you first to create the first project first before you save. Now I will explain you briefly from the left side to the right side. For the quick design wizard, it is easy for to help you to design step by step from the first step to the finish step. And for the import a tab file, you can import 3D model from the tab into directly to the CSI column and design only for the column. And for this option, you can import from the previous option, previous version of the CSI column, and from here you can create the new blank project. And from here you can design for the rectangular section, and this one for the circular section. And for other section you can use section designer. You can design in the blank section, but now I has to start from the quick design wizard. It easily to design from for the beginning level. Just start it. You see here it's a step by step show you how to define the first project. Now let's say it the project 1 close. Unit and code. Unit, I has to select SI unit. You can use for the impress unit. Code, you can use the SVI code, BA code, China code, Canadian code, or Europe code, Hong Kong, Indian code, Korean code, Mexican, Singapore, etc. Now I select Europe code 2. It is a certificate for concrete. It is for certificate of the steel. And you can hide other option. Close the column. Okay, column 1. You can select for spiral column or tie column. For the option I have to design for rectangular column, I select tie column. Wow, what's wrong? Oh, material. I got for material. Now you have to select one material, but now you cannot select because after complete this step, we will add more material property and this it. Now I just define from the default option. Close. You can continue to other step. You have to complete 1 step, 2 steps, 3 steps, and to do the next step. Okay, it's like a rectangular. I keep everything here. It is the same as the default. And you can add more rebar in the 2 direction. Okay, 2 direction, 3, 4, or you can change rebar diameter as you want. Here I can add 2. Okay, minimum clear spacing you can increase, and the section you can change section to what you want. Okay, consider slenderness. Okay, for the long column, for the unpressed or pressed column, for the square or non-square column, you have to define consider the slenderness. Define framing. You can define for the fixed support, pin support, or for the other type frame. But for accuracy, I have to define for the general case. If you don't want other side beam to include in your calculation, you can exclude this thickness. Okay, but I has to consider all beam in this direction, so I click all. Okay, you can zoom in, zoom out. You see here in the plane X Z plane, Y Z plane, or 3D. Now I want to use in the 3D. Click here. You can see in the 3D model. Use your left mouse and can rotate it. You have to define in one plane, in each set plane, and for the each set plane. Now I have to define from the first plane. Okay, the top column 4 meter, the bottom column 4 meter, and for the design column here, the design column, I use 5 meter. Okay, 5 meter, and for beam length 6 meter. Okay, 6 meter. You see it the same 6 meter, and for other plane I define the same, but different length of beam. Okay, you can use 3D again. Okay, you have to define load. Now I use the default load, and you can consider your column as the preframe or unpreframe. You can click on the option. If you consider your column as unpreframe, you have to calculate the sphere sensitivity before you know the column frame or unframe. I recommend you to read the code, or you can analyze in the 3D model in a tab or in other software. In the tab for CSI code, you can compare the second moment analysis with the first moment analysis or in column is greater or is equal than 5%. So you have to consider the column as the unpressed, and is smaller than 5%. You can consider it. The column is a break column, and for the European code, you have to check with the critical factor is greater than 10. It considered as the non-sphere or break column. Is less than 10. We have to consider as the unpressed column or sphere column. Now let's start. You can check it quickly. You can design show the capacity ratio is 0.81. Okay, for the load moment in both direction, close. You can view the detailed result. Interaction curve. You can define the number of curve 24. You can check here, or you can define it. Example 11. Okay, you can check the combined top. Okay, you can check combined at top and combined at bottom. You can see it is the capacity curve. Now our action or our load is inside the capacitor. So our column is says Now we have to explore more in the option. In the material, you see it here concrete as imperial unit. Now we have to define the new material in SI unit. Click on the icon, and in the concrete you click on the icon, and in the library I take concrete from the job print. Okay, C38. I click it again to add the rebar from the China. Okay, the rebar from the China, strength 408. Okay, and you can add other from the other standard, Indian, Italy, Russian, Spain, whatever you want. You can click add steel, add rebar. For steel is refer to hot root section, or it rebar. This rebar refer to rebar in reinforced concrete. Okay, D20, D25, deform rebar. Close, and in the columns you can check it again if you want to correct the shape of column or dimension of column. Now I have to select material. Okay, material, compute for the confinement zone. Okay, I have to select a confinement zone. Rebar. Okay, for rebar I had to choose the new material HIS from the previous. Okay, now let's continue to the framing. If you want to edit framing, you can to edit it again, and section also. Loading, you can also correct in the loading. The combination, consider sway. Okay, you can take account or sway into your frame. Okay, into your column. You check the bottom. Okay, I has to consider sway to into the column. Now let's check section property. You see area of the rectangular section, shear, energy, total weight, radius gyration, everything in detail. Section elastic. Okay, design capacity. Okay, if you consider the effect of p data and p data, big p data, and small big p data. So our internal load is over the capacity. You can check here for this column. If you do not include the effect of the second of the effect, the column it pass. You can check again, consider about the slenderness effect or not. But in the loading, it is very important. In loading, you click in loading, the combination. You have to consider the sway effect or not. Your frame is sway or non-sway. But in the slenderness we have in both in the sphere frame or non-sphere frame, and for the unpressed on press frame also has the slenderness effect, but in the sphere frame, if we consider it the sphere frame and we activate this option, the member will be calculate the p data, big p data effect and also small p data effect. So you have to check the option. Now I try to check slenderness effect and with the consider this way. So let's check the design report. Okay, it is the design report. The design report, the pressing condition, unpressed. Okay, you see clearly unpressed, or in ACI code or ASCE code is called sphere. Okay, sphere or sphere sensitive sphere column. So you have to check the extra moment from the first moment and from the second moment. Here the design moment, the nominal effect from the second order effect. Okay, you see here when you consider the slenderness and your frame or your column is a sphere column. So in the calculate has to include all this moment to extra to add more on your section, and you check the capacity ratio. It's over. It's 1.75. Okay, 1.75 is over. Now it's a antique consider sphere, and you have to select on other part. Okay, column, and regenerate the report again. These are detail report, and you can check it quickly. You see the design ratio is 0.74. What does it mean? Okay, I has to check again and load combination. In the case we has not considered the sphere, so our frame is press frame. Okay, the press condition is press frame, or in ASE is called the non-sphere frame or non-sphere column. So it's not include the p data effect. So your column is pass. But when we consider the column is sphere, you must be tick the option. Slenderness effect. Okay, you must tick the option to include all effect in your column. Okay, and to regenerate the detailing report. And let's check your frame again and press. Okay, it right with our concept here. Yeah, I'm sorry. It right with our concept low combination, consider its way. Okay, and press it right, and you can check here more for the other extra moment here about the first mode, first effect and second order effect, and the design ratio is here. Okay, in the sphere frame you must be consider about slenderness effect. Okay, but in the slenderness effect also include both for the sphere and unsphere. But when you consider the sphere and you must check here to check all full option, and you can try it by yourself, and you not include slenderness, and you generate the report again what is wrong with that. Okay, the capacity is now 0.54, and you check your frame, where your frame is frame and frame not included here, and you can check it. Fiction property, okay. Now I has to check for the slenderness, and I consider the column is fake from the sphere is fake column. Now you can check for the capacity detail, for the animate interaction. You can check here animate interaction. Multi-core design load, okay. Design your resistant, you can check here. Design ratio not okay. Low capacity, you can check here. Low capacity, you can check with only load capacity only, capacity only. Okay, it's over our capacity. You can check everything from here, and thank you for your watching. Painting in digital code, it is big P data, and for the curvature in the member, create one small data is equal E2 in the report. You can check here reflection E2, and for the geometry imperfection first order, okay, 0, 1, 2, second order moment effect from the slenderness adds more moment in our column. Okay, now I have to explain you about the P data concept applied on our column. You see, when we not consider the P data effect, our column it pass either capacity can resist the applied moment or applied force, but when we consider the P data effect, our column will be fair because the effect create more moment. The column cannot resist the applied load. Now you have to understand what difference between a sphere and non-sphere structure refer in ASCE or CSI code, but in general code it not defines sphere and non-sphere. It defines in the BA code it defines the press or unpressed, or we can define it actually on the critical load factor or or stability index in the ACI code. Now you have to provide, you have to check the example. Provide the deflection is small, structure is non-sphere, so we have to consider about the deflection or deformation of the structure. This part is very important, so we have to check the deflection. And the second order effect can be ignored. At the level, effects are no longer structure is very sensitive, so you have to include second order effect in your column. If you run the global of your structure and your structure is non-sphere, so you has not to include the second order effect. But if your structure is sphere sensitive, so you has to apply the second order effect. Now let's continue. You see here the big P data, and this one is the small P data. Small P data. The member curvature introduce a small P data between the member. Okay, small P data. As I show you the previously, in the zero code is the E2. You can check the E2 in the report when you consider the slenderness effect in your column, and you check the detailed report. You see here in the report is include the P data, big P data and small P data, and include geometry imperfection. Okay, here the geometry imperfection of the member, here the first moment, and this one the deflection E2. This is the small data. So your section resists a large moment compared with the column without the slenderness effect. So the design review is over. In the case, before you use this software, I recommend you has the clearly understand between the global effect, local effect, or the structure in the 3D model or in the frame. So you have to classify your column first before you design in CSI column, to avoid serious mistake that can create before you do not understand what input in this software. I just recommend you to check to collect more concept about design column. Here I just go to tell you about what in the calculation node do, and you have to check with the small part for the short column and slender column. In our structure, for the supporting member, for the column member, we can classify short or slender column, or you can also call a short column or long column. For the short column, in case of non-sphere, so the second order effect can be ignored. Okay, you not include the second order effect in analysis to make extra moment in the section. But in the slender column, but non-sphere, in slender column non-sphere, the global effect can be ignored, but the member effect might be considered. Okay, you have to consider the imperfection in the member. And for the short member but sphere, short member sphere, the global effect must be considered. You must be considered, but the member effect can be ignored. And for the slender column and sphere, you have to consider all effect in the column. The global effect, okay, the global effect consider, member effect consider, you have to consider about big p data and small p data. You have to calculate the value to make extra movement in our section. Thank you for your watching, but don't forget about the concept applied for two direction. We call our section, we has two direction in it and y. We has our energy in it in y direction, strong axis or weak axis. So the concept also apply in the both directions. Sometimes your column in a strong axis is in short column, but in the weak axis in the slender column, it depends on the dipole beam. When direction one has a wider dipole beam and one other direction has a lower dipole beam, so you can classify it, the umbrella length or the length or actual column depend on its direction. This is the conclude of our tutorial about the pre-calculation column depend on software CSI Column. I have to recommend you to check the basic concept of column sphere or non-sphere before you use the software effectively. Thank you in advance. Thank you for everyone to watching my video. Thank you. I hope you can gain your knowledge in the right way. Thank you.